I'm Jörg Belz. I'm from the German Aerospace Center, and today I will explain you how Android can improve mobility of the blind and visually impaired people. And we have a research project, or we had a research project in that we tried to improve mobility of the blind people. First of all, what is DLR? How many of you know DLR? Maybe like, yeah, it's pretty good. Maybe like 10 persons. So DLR stands for Deutsches Zentrum für die Raumfahrt, which is German Aerospace Center. And it's mainly known for aerospace. So we contributed to the Philae lander, which was part of the Rosetta mission. We are also operating the Columbus Space Center, which is organizing or surveying the satellites or the space missions for Europe, for ESA. And for example, we also have a telescope which is mounted basically on a large airplane, on a Boeing, and this is together with NASA, for example. But that's not all. We have security, but also space, as you said, as you just saw, and aeronautics, transport, and energy. And as far as I'm concerned, I'm from the transport department or transport branch. More specifically, I work in the Institute for Transportation Systems, which is located in Braunschweig and in Berlin. So on this map you can see that we have around 16 sites in Germany, and we have around 8,000 employees. And in my institute, we are working in research and development for automotive, for railway systems, for traffic management, and for public transport. I'm from the automotive branch there. And yes, that's so far for the DLR. And what I will tell you today is, I will tell you a bit about the InMoBS project, maybe 20 minutes. And then I will explain a bit about accessibility in Android, how does it work, how you can improve your app. And in the end, we will have time for some questions. So first part is the research project InMoBS. And InMoBS, the project was done by several institutes or companies. The Technical University of Braunschweig was leading the project. Then was the DLR and some companies, Ökon, Siemens, and Transfer. Siemens you probably know. And there were also subcontractors. Most importantly, the German Association of the Blind and Partially Sighted that supported us during the project. I will have a short video now to give you some insight into the motivation that we had to make this project. Is there sound? No? Wait a second, maybe it's... Wait. Yes. Das Mikro anhalten. Ausziehen, Mikro am Lautsprecher halten. Ja.
So, die Frage ist natürlich, hast du den Sound vielleicht ausgemacht?
Nee, ich habe es gehört.
Just a second.
Blind and visually impaired people encounter many obstacles as they navigate public spaces. Everyday situations, for example a trip to the bakery or the doctors, are much more challenging for them than for people who can see.
Ich bin von Geburt an sehbehindert gewesen und die Augenkrankheit heißt Retinitis pigmentosa. Das heißt, man verliert langsam die Lichteinwirkung und vor ca. 25 Jahren war ich dann im Endstadium angekommen, hatte keine Lichtwahrnehmung mehr. Mobilität für einen nicht sehenden Menschen ist äußerst problematisch. Um sich überhaupt in Verkehrsflächen bewegen zu können, ist einfach der Langstock das Standardwerkzeug, um auch Hindernisse entsprechend wahrnehmen zu können. Man hat als Nichtsehender, der keine Lichtwahrnehmung mehr hat, natürlich keinerlei Möglichkeit, sich zu orientieren und die Gefahr des Verlaufens ist doch sehr stark gegeben.
Okay, thank you. So as you could see, it's very difficult for them to navigate in urban environments, especially when there are traffic around. So to get to know what they actually need, we did a requirement analysis, and to this end, we worked very close together with the blind people and the partially sighted people. And there are some tools that are here that we used, like phone interviews. We did an online survey. We also observed use cases and looked at how do they feel, what are their fears. And one important tool was the interviews that we did. We developed a prototype of the app. Then we gave this prototype to the people, to blind people, test users, and asked them what can we improve, and looked at them. How do they interact with the device, and encourage them to think aloud, so that we actually know how do they feel, what problems do they think they have, and what could be improved in the application. And so this was then we had like a iterative development process where we improved the app after a few weeks and gave them another version of the app and improved it further. This was done in cooperation with psychologists from the university. And here I will tell you some of the challenges that we found. One is noisy environment in the cities, as you can imagine, because there are a lot of traffic. They really rely on a sense of hearing, and if there's a lot of noise, it's difficult for them to navigate. And another challenge is at some crossings there are intersections that are equipped with some special equipment that makes noise for them to assist. But a lot of intersections are also not equipped, and this is a challenge. And also unexpected obstacles like construction sites or poles in the middle of the street. And bicycle lanes that are crossing or they are parallel also, so they are in danger of getting on the bicycle lanes. And tripping hazards like tram rails that are going in the middle of the street, so they don't expect that, and they trip over it, and it's very dangerous for them, especially when they're crossing this intersection. Also, if they don't know the crossing geometry, it's very difficult for them to estimate, for example, how long do I have to go to get on the other side of the street? It's like 5 meters or 10 meters. Is there a traffic island in the middle of the street or not? And yes, that makes it very difficult for them. And lowered curbs also add to this difficulty. These curbs are good for people in wheelchairs, but for blind people, they use their white cane to navigate and to figure out if they are on the street or still on the pedestrian walkway. They need to find the limit or the border between the street and the walkway. And this is much more difficult if they are lowered curbs. So if they don't know that they are lower curbs, they are in danger of ending up on the street or accidentally going up on the street when they don't want to go, when they just want to go to the waiting area of the traffic light, for example. And so all these challenges, these are not all challenges, but are major challenges. They lead to that the mobility is limited to trained routes. So they go the routes to someone seeing, and they explain it. What are the difficulties? Where are dangerous situations or dangerous places where you should avoid? And this leads that that they go only routes that they already know. And so the major reason for their constrained mobility is the lack of information they have, and we try to improve that for them. Some information is already there. We just need to use it. And in Braunschweig, the city that I come from, we have the test field, which is called AIM, which is Application Platform for Intelligent Mobility. And in this test field, we have, among other things, car-to-X communication, which means that when you have a car that is equipped with some communication module and you are driving along this test track, you can see in your car that the traffic light is going to red in 5 seconds, or the traffic light is staying green for 10 seconds, for example. And this information can also be used in the automation for the cars and has already been used in some projects. And now the idea is to use that information that we get from a traffic light also for this navigation app. So, for example, the people can see on their smartphone when it's getting green. And here I will have a short system overview. I will not go into that in detail, but just point out the major components. We developed a server platform, which purpose mainly is to this routing, and it has the digital maps for the routing, and there's also a web server which serves to a website that is especially designed for the blind people and the visually impaired people, so that they can plan their routes on their own computer. Blind people are very good at using the computer if the website is designed for them. So this is actually not so difficult for them. And they are at home. They can do that maybe with some assistance of a blind person, of a seeing person. And yes, that is the purpose of the website. And then we have the traffic light, which is transmitting information about the traffic lights. And then there's the app. We also used an GPS receiver, which is more accurate than the GPS sensor that is on your normal mobile phone to improve the accuracy of the positioning. And here you can see the app. And as you can see, it's a very simple layout. It doesn't look very fancy, but it's very consistent and very easy to perceive for the blind people, because it's always the same layout. The same things are always in the same place in different menus. And it's also high contrast. Nowadays you can change the contrast, adapt it to your, for example, your color blindness in the Android system. Back then, we developed for Android KitKat. It was not possible to change it there, so we also implemented several color contrasts for the people to see that. And interaction with the device was done using Android TalkBack. I will tell you more about how that works later. But basically, it's the people can explore the display by touch. So if they touch some elements, some view, it's that the device is reading out the description of the view, and if they double tap on the screen again, then this view is clicked in like you would normally click a view or tap a view, and an appropriate action is executed, like starting a new activity, for example. So the main goals for this navigation was to keep the user on the route, because we planned the route specifically to be safe, like to avoid difficult situations, to avoid obstacles, inform the user about surroundings and obstacles, hazards that are on the route, and in particular support the user at crossings. So here I will show you some functionality that we implemented. To keep the user on the route, we used vibration feedback. So the user can feel if he's going in the right direction or not. And if he's deviating from the route, the vibration impulses lead him back to the route. And I have a small example here. For example, if the user is located at a position that is pinpointed there by the circle, and he's going in the direction like in the top left, the vibration impulses are slow, because he's going the right direction or going back to the route. But if it's going in another direction, the vibration impulses are fast, and so the user knows he's going the wrong direction and can adjust his heading accordingly. Second one was to automatically announce turns in advance. So the user is going on a route, and we know he has to turn left in 5 meters or in 10 meters. And so the user gets an announcement about that he has to turn, and he can prepare about it, and so it gets easier for him to also foresee what is coming. And to keep the user informed, we also automatically announce points of interest and obstacles that are on the route. For example, construction sites, but also supermarkets or post office, something like that. And for construction sites, in this example, you can see that there's a warning that obstacle construction site is in 10 meters at 1 o'clock. And 1 o'clock is, it's not a time, it's a direction that the obstacle or the point is in. So you can imagine like a clock, and it goes from 12 to or from 1 to 12, and depending on the direction, the person gets the correct announcement. That is something they often use for orienting themselves in the city. Furthermore, the user could also, on demand, announce more information about the route, about how long is the route, or how long do I have to go, how many intersections do I have to cross, and what obstacles do I still have to face, and how are the intersections equipped, and yes, about also points that are nearby, that are not directly on the route maybe, and also about the current position of the user, like he's standing in this street and in front of house number 11, for example. And very important was to support the user at crossings. To this end, we read out very detailed information about the crossing. As you can see here, like this basically the information that the user was missing, like the type of the crossing, is there a signal or not, are there low road curbs, is there a bicycle way or not, and so on. And the second support that we gave the user is to announce the green light. For this, as I mentioned already, we used the Car2X communication, which is based on, it's called ITSG5. And we needed to adapt the hardware to support the consumer Wi-Fi. And when the user is approaching the crossing, it connects to the Wi-Fi that is on the intersection, receives a signal about the traffic, the signal state, and about the topology of the intersection, and then uses this information, matches it with the route. And so on the route, you can see what intersection or what crossing the user has to cross. And when the user arrives at the waiting area and is aligned correctly, he's giving the green signal to cross the intersection on the mobile device. We did an evaluation of the system with blind persons in Braunschweig on a small test site, or small, yes, on some intersections, like here, we did 3 intersections were equipped using the system, and the feedback was generally positive. And especially the information that we gave to the user was important to them and helped them a lot to navigate themselves and to be aware of their surroundings. And also the information about the green signal was transmitted very reliably, which we weren't sure about before, because this was the first time someone tried something like this. We had problems with positioning. Positioning was good or accurate enough most of the time, but not always. And even if it's just 5%, it's not enough for a system to be able to be used by the people alone, because if the system is not accurate enough, it's giving information that is incorrect, and this may lead to dangerous situations. And we also saw that sometimes there were difficulties in using the app, but these difficulties were mainly caused by the lack of using touch devices. So most or many blind people still use devices that has like physical hardware, physical buttons, and they are not used to using touch devices. And even if the assistance functions like TalkBack are pretty good now, if they're not used to it, it's very difficult for them to get into this and use the system, and then also to use our app. And here I have some of the lessons learned. Well, the basic lesson that we learned is that it's very difficult to have a good balance between the features that they want, because they want a lot of features, and to make it as simple as possible, because they also want to have it as simple as possible. They don't want to be distracted during walking around, and they don't want to like hear an announcement for half a minute before they can continue walking, but also they want to not get a lot of information. And that is very difficult to have a good balance between these things. But in the end, it's better to have a more simple system, because that also improves usability, than to have a complex system that has a lot of features. And well, UIs should be as simple as possible. And even standard elements such as lists, like scrolling a list, selecting items from a list, are difficult to use by some blind people that are not used to the system, and that is also something that was surprising to me. And last but not least, asking these people to test your app really helps you in improving the app in regard to accessibility. So here I will show you a short video about how the app works in the end. I'm not sure if the sound is working now. Yes? Okay. Let's try.
InMoBS comprises a smartphone application and a route planner. User navigation data are registered via GPS and implemented via the app. Users receive information via vibrations or voice messages.
Benachrichtigung, meine Routen werden abgefragt. Gehen Sie geradeaus auf Revenring für 58 Meter. Ein Fahrradweg verläuft parallel.
The new system will make it easier for the blind and visually impaired to orient themselves on city streets and cross intersections more safely.
Das bedeutet, dass hier wirklich die Grün- oder Rotphase von der Lichtsignalanlage, von der klassischen Ampel an das Smartphone übertragen wird. Und somit ist es sichergestellt, dass der Blinde hier sicher die Kreuzung überqueren kann.
Andere Gefahrenquellen, die uns natürlich spontan überraschen können, sind natürlich Baustellen oder Dinge, die jetzt überhaupt nicht vorher vorausgeplant werden können. Da haben wir ja in InMoBS auch die Möglichkeit jetzt geschaffen, dass wir solche temporären Störungen im Wegenetz auch darstellen können und entsprechend gewarnt werden können. Die Zukunft liegt darin, dass wir noch mehr Flexibilität erhalten, dass wir noch mehr uns ohne Begleitung, ohne fremde Hilfe im öffentlichen Raum aller Art bewegen können. Ja, es ist ein großer Schritt in Richtung Inklusion.
Sie haben Ihr Ziel erreicht.
Okay, so this was one of the test users that was testing the app in this area in Braunschweig. And well, we had about 20 test users that we used in the field for testing the application, and even more that we asked for improvements during the development process. And so what's next? The application or the system that we developed, it's a research prototype, so it's not available on the Play Store to use for everyone, because as I said, it's not reliable enough, and it just covers a small area, and the positioning is still not accurate enough, and needs to be improved. It could be improved, for example, by adding beacons to the infrastructure, and which is costly, but could improve positioning and also enable positioning indoor, which is also important, especially when using public transport like trams, buses, or subways, which is essential for mobility of blind people. That is also something that was not included in the project. It was not the focus of the project. Focus was to cross intersections and navigate outdoors, but it's basically necessary for them to use that. But the knowledge that we had and that we acquired and the results that we achieved is already being used in other projects. For example, the communication between the smartphone and the traffic light, or traffic light is being used in projects to improve safety for pedestrians, for cyclists, by communicating with cars, for example. So if you're going by bike and you are occluded by some vehicle that is parking on the side, but there's a car going on the street and is about to turn right, we can inform the car, the driver about the cyclist that is going parallel to him, so we can brake and avoid an accident. And there's also a website for the project. It's in German, unfortunately, only. And there's a final report which is much more detailed than what I could have given you today, which also covers the other components that we developed. And there's a a small article or like a 2 or 3 page article in a magazine that's in English. And I really if you're interested in a topic, I recommend to read this article because it gives a good overview of the system. So now it's part 2, accessibility in Android. So maybe that's the most important, the reason that you actually came here. And we already heard in the previous talk by Leonie some things about accessibility, and maybe sometimes I will repeat the things you already heard, but maybe a few things will also be new to you. So how does accessibility in Android actually work for the blind people, for instance? So basically you have a user interaction, the user perceives what is on the screen, he thinks, or hopefully thinks, and then acts and pushes a button, for example. Perceive usually is done using your eyes, so you see what is on the screen. For the blind people, or for the blind people, for example, they cannot see what is on the screen. Deaf people cannot hear what is the device is saying to them, and so on. And this limits the perception and thus also limits how they can interact with the device. To solve this, there's a so-called accessibility service. This is a layer between the app and the user that adds additional feedback, so the user can still interact with the device. And this service listens to events that are sent from the view to this service and then adds some additional feedback to that. For example, events could be like the focus changed, some content changed. Like, for example, if you have a text box and the content changes, a blind user cannot be notified about the content change, or you have to explicitly notify him about that. And this is done in the form of accessibility events. And so now you're wondering, what do I have to do actually? So there are 2 good news. The first good news is that this accessibility service already is there, so it's for free. It's called TalkBack, and it's in Android included, or you can download it in the Play Store and enable it on any recent Android device. And the second good news is that the standard views that are included in Android also work together with these accessibility services. So they already send these events, these accessibility events, to notify the service about some changes or something that happens. So what do you still have to do? There are a few points that you should consider. And the first thing is to just download TalkBack and enable it on your device. It's like you can download it in 1 minute and then just enable it and see how it works. If you have never done it, I really recommend to do it, because and then just try it on your own app. If it's just for 5 minutes, just to see how does it work and how your app works together with that. And the second tip is to use content descriptions. These are really, really important for the blind people, because when you have a button that is displaying an image and this accessibility service reads out this image, it needs to know what is the semantic of the image, what does it say. And if it's just an image, there's nothing it can say, so you need to add some information, some text information to this image. This is done using content description. And this is applicable to icons, image buttons, but also to your custom views. So if you have a custom view, you should add a content description, at least if it's necessary for the user to interact with that button or with that view. The second, or another tip is to keep in mind the focus navigation order. There are some possibilities in this accessibility service to just iterate through all the views. So you can just say next view by swiping, for example, but also by using an external switch or some keyboards that are there. There's some external hardware or software keyboards. But to this to work, there is some default order, but maybe it may not be very good for your application. Maybe you want this item to be displayed or to be read out to the user after that icon or that item, and then you have to set this order explicitly. It's just that you have to set that in the layout file and set a property accordingly. And if you are creating custom views, you should send accessibility events, such as if something important changes in this view, like some text changed, send an event so to notify the user. And also, yes, that's basically the same, but it also applies to your standard views. There's an attribute that says accessibility live region. The name may be not very self-explaining, but basically it means if something in the view changes, should I notify the user? And if I should notify the user, how should I notify? Should I give him non-feedback? Should I notify him in a polite way, like first wait until some other text that is already read out is being completed and then read it out? Or should I wait, or should I immediately read out this change because it's very important? This is assertive. And well, this is basically very obvious, but make the touch target sufficiently large. Yeah, that also applies to users that can see the screen, because sometimes it's very difficult to touch some specific view. Even for me, I also sometimes have the problems, and it's very annoying. And something like this, like views that are moving, views that are disappearing or suddenly appearing, and layout that is very different across activities. It's very difficult for blind people to use this application, because every time the view changes or the layout changes, they have to again figure out where is what menu, how can I go back, and I want to go to the settings. Where's the settings? And if it all changes, and it takes a lot of time for them to get used to this application. And yes, avoid low contrasts. This also, yes, very self-explaining. Do not have like an application that has low contrast, especially with text or with buttons, so they can see that. And there are very well written guidelines by Google to how to make your app more accessible. And the last link that is here, there's also it's a presentation about how to do the testing of accessibility, how to automate that to some extent. So to check for missing content descriptions, for example. So the take-home message for the day from this talk is, well, it's a fact that there are potential users of your app that have some visual or some other physical impairment that makes it difficult to use the device. And often it's just with a few easy steps you can make your application much more easier to use by them. And for example, adding content descriptions. And most of these steps also apply to everyone else, like inexperienced users or older users who are not used to using smartphones. It's making life for them easier as well. Okay, so that's my presentation for today. And yes, thank you for your for coming and listening to my presentation.
Thank you, Jörg. And we have enough time for questions. 1, 2.
Thanks a lot for the awesome presentation, and this is a fun project. And I just have the question, battery consumption is a big issue with Android and smartphones in general. Mm-hmm. And if you have your device to be always on and also give a lot of vibration feedback, how long for example, if you want to have to walk a route, what was the longest time you could do with your prototype?
Actually, something that we didn't test. It was a research project. It was not supposed to be given to the users. I like to be used by everyone. But that's a good point, actually. As far as the display is concerned, in the new Android versions, you have the possibility to dim the display. So you actually don't have to have full display brightness all the time. So you can dim the display, so the blind users don't have to see the display anyway. So they don't have to. The display doesn't have to be on. As far as the vibration is concerned, yes, of course, I understand that's an issue. I think, well, the thing is, the vibration was only intense if the user is going on the wrong way. So if the user was going the right way, it was like every 5 seconds or so. It was just there to notify the user that the system is still running. Could also have been 10 seconds or even longer. Or you can figure out another way to notify the user that the system is still running. And so vibration feedback was only necessary in these cases where the user was not on the route, and this hopefully is not the case all the time.
Thanks a lot.
Yeah.